1.4, really quick review, little warm-up. This is something that you should be fairly familiar with. Y equals a, x minus h squared plus k. Independent variable, dependent variable, parameters, a, h, k. What are the roles of the parameters a, h, and k? It's just a little warm-up, you know?
Okay.
It's not on there.
Okay.
Just throwing it in there.
We have like bonus stuff on ours. So.
Yeah. What does A do? What does H do? And what does K do?
A is vertical compression or stretch.
Thank you.
Compression.
Vertical stretch compression. What else can it do?
Negative or positive. We can flip the function.
So I got direction of opening. Negative will have a max, opening down. A positive will have a minimum, opening up. Good. H. Give you a hint. It starts with the letter H.
Horizontal translation.
Nice.
It's like phase shift or something. I forgot.
Yeah, when we're talking sinusoidal. Horizontal translation, because this is just a quadratic. Good. And this thing, K. There's only one option left, really. Vertical translation.
Horizontal translation.
K is the vertical. H is horizontal.
Oh, I was looking on that paper.
Which tells us that the vertex is at HK.
Yeah.
Okay, this is in the case of a parabola. It's in vertex form. When we're talking about transformations of polynomial functions, it's really helpful to have things in, this type of form. So we're going to be looking at things in that context, and we're going to be talking about the transformations. We're going to be adding a parameter. We're going to be adding the parameter, kind of mixing around the parameters a little bit. K is actually going to go somewhere else and do something different. And D is going to take its place way out there. C actually. Anyway, we'll get into it when we get there. So here we go. Example 1, coming right into transformations of polynomial functions. You have the graph of y equals x cubed is transformed to obtain this new graph. The new graph is y equals -3 square bracket, y equals -3 square bracket 2 round bracket x plus 1, close that, square off to the power of 3 plus 5. Okay, there's our new function. Its parent function is y equals x to the power of 3. And then a bunch of things have happened to it. So what has happened to it? Well, if we look at our kind of skeleton function here, a, k, x minus d plus c, okay? 4 parameters, all doing different things to it. Just a quick review. The k is a multiplier in front of x. It's going to cause stretch compression horizontally. Yes? The d is being added or subtracted from x. It's here in the bracket with x. It's a horizontal translation. It's going to move the thing left or right. C is way out here after the shape has kind of been decided and it's added or subtracted to the whole function. It's just going to move the whole shape up or down. Okay? And A is out here. It is a vertical stretch compression. It can also flip it, open up or open down. Okay? So here we go. We're just going to look at example 1 and then take some notes on this afterward. So we're going to state the parameters, describe the corresponding transformations. Kind of already did that, but that's okay. Let's go through it again. So we've got K. It equals 2. Yes?
Yep.
Therefore, we have a horizontal
stretch.
Yeah, this is the tricky one. Remember, it's actually a compression by 1/2, 1 over k. All right, so that's the hard one to remember. It's going to be a compression of 1 over k. Well, what does that mean for the table that we're going to fill in? It means that we're going to, and I'll write this in a different color, we're going to divide x coordinates. We're going to divide the x coordinates by 2. All right, let's look at A. A in this case equals -3. It is then a vertical stretch by a factor of 3 and a reflection in the x-axis. Okay, so what are we going to do? We are going to multiply the y coordinates, because it's going to change this thing vertically. We're going to multiply the y coordinates by -3. And then we're going to apply our translations at the same time. So we've got d equals -1. That is a horizontal, sorry, not -1. D equals, I copied down, oh no, there it is. Yep, d equals -1. Therefore, horizontal translation, 1 left. And C equals 5. That's a vertical translation, 5 up. How do we apply those if we're rewriting our coordinates from column to column, as you see in the little chart below? Well, horizontal translation, 1 to the left, just subtract 1 from each x coordinate. And how do we move it up? Well, we add 5 to each y coordinate. Okay, it's very important that we do the multipliers first, k and a first, and d and c we do last or second. Okay, so we're going to do our multipliers first. That gets the whole shape of the polynomial, and then you move that polynomial around. Okay, if you move it and then change the shape, you get a very different answer. Okay.
I just did it by like order of operations.
Yep. Order of operations.
Makes the most sense. At the end of the day, it's how the computer does it. So.
Yes. Okay, look at your chart there. I'll quick jot down your columns. What you do here, since it's a cubic, is the parent function would be y equals x cubed. So the basic starting points closest to the origin that are easiest to work with, -2, 8, -1, -1, goes through the origin, 0, 0, then it goes through 1, 1, and it goes through 2, 8. We're going to apply these transformations one at a time. The first one that we're going to apply is k. So all we're going to do here is say, now we don't have, and look, k is in here. It's in here in the square bracket with x, and then it gets cubed. Okay? So that's why it goes in those brackets, 2x, and then that whole thing gets cubed. So all we're doing then is what? Dividing the x coordinate by 2. So instead of -2, -8, we have -1, -8. Instead of -1, -1, we have -1/2, -1. Instead of 0, 0 stays 0, 0. So again, we haven't moved it at all, right? 1, 1 becomes 1/2, 1, and 2, 8 becomes 1, 8. All right, so now we take that one and we're going to apply our vertical multiplier. Okay, we're going to multiply that whole thing by -3. So we've got -3 in brackets, 2x, close bracket, to the power of 3. And we already broke down how we were going to do that. So our next column, we're just going to take our y coordinates, multiply them by -3. So instead of -1, -8, we're going to have -1, and then -8 times -3 is 24. Again, the x coordinates are all going to stay the same. 0, 0 is still going to be on there. Our second coordinates, our second point is going to be -1/2, +3. Then we're going to have 0, 0, and then 1/2, -3, and then 1, -24. Again, just multiplying the y coordinate by -3. And then we're going to apply our vertical and horizontal translations together, which gives us our whole equation here. -3, square bracket, 2, round bracket, x plus 1, close round bracket, close square bracket, to the power of 3, and plus 5 at the end. So here, what are we doing? Well, from the x coordinate, we're going to subtract 1. From the y coordinate, we're going to add 5. So our first point turns into 0, 29. Our next point turns into half.
Add one or take, subtract?
Oh, yep, you're right. It's supposed to take away. Okay, so -2, 29. Then we're looking at -1.5. And the y coordinate is 8. And then we're looking at -1, 5. Then you're looking at -1/2. And we're going to add 5 to -3. That gives us a y coordinate of +2. And then we are at 0, -19. Now you can take these points in that last column and you can plot them on the grid and graph it. Okay, so the original cubic, x cubed, is there for you as reference. But go ahead and try and plot this. And should find out, it should look something like that. It's much less smooth, right? It changes direction a lot more quickly, going up and down. And its little apex turning point here is at -1, 5. Okay, quickly, domain and range. Any restrictions to the domain? Anything I can't put in as a value of x?
No, it's just
Keep
x set of real numbers, y set of real numbers.
good. Range is the same, right? It goes all the way up, all the way down.
Think,
No restrictions.
yeah. I was gonna say there might be a restriction.
Okay, a couple of notes on the top of the next page. Last lesson, we just talked about even functions and odd functions. So we're going to talk about that briefly. When equations are in this form, they're easy to work with and to see things about. So when an equation is in the form y equals a square bracket k round bracket x minus d close to the power of n plus c. When they take this form and n is even, okay, so your exponent up here, that's what we're talking about, is even, the function is even, not just even degreed. If it's in this form and the exponent is even, if you were to expand it, it would result in only even degreed terms. Okay? So it is an even function when it's in this form and n is even. Okay? Even more helpful, and has a vertex at DC. Okay, very similar to a vertex form with a quadratic. This time it doesn't matter if it's, the function is x to the power of 4, x to the power of 6, x to the power of 8, x to the power of 122. Can't be odd, obviously. It has a vertex and tells us what it is. Okay? The axis of symmetry, should be able to intuitively get this. The axis of symmetry is the x-coordinate of the vertex. So it's x equals d. Just like if you had a quadratic and the vertex was here, the vertex is where the parabola meets the axis of symmetry. Okay? For a greater than 0, so positive leading coefficient, which way do you think the graph opens? Graph opens up, and which makes the vertex is a min. Range is y belongs to the set of real numbers such that y is greater than or equal to c, right? Which is the y coordinate of the vertex. Same note for a less than 0, for negative leading coefficient, okay? If it's negative, the graph opens down. The vertex is a max. And range is y values belonging to the set of real numbers such that y is less than or equal to c. So a lot of information we can get from an equation in this form. Example 2, we're describing transformations from an equation, okay? So step 1, we're going to describe the transformations that must be applied to the graph of each power function being the parent function that's given. So in A, you can see the power function given is f of x equals x to the power of 4. And then you have the transformations that need to be done to that parent function. Then we're going to write the corresponding equation. And after we do that, we're going to talk about the characteristics, the domain and range, the vertex, and if there's symmetry. Okay, I'm going to write down the first equation that we're working with, which is f of x equals x to the power of 4. Transformations that we're going to apply, we're going to talk about the parameters. So you can already be thinking about what a, k, h, d, and c are, not h. And I copied that wrong. 1 over 3, x minus 5. Close it off. All right, what are the parameters? A, what's the value of A? 2. What is the value of K?
1/3.
1/3, which means a horizontal stretch, right? By a factor of 3.
Yeah.
A is a vertical stretch by a factor of 2. Good. C and D. We've got a D.
D is equal to 5, C is equal to 0.
D is 5, C is 0. Okay, I'm not going to jot down what each of these things do. We've done that enough. But here we go. We don't even need to graph it. We just need to write the new equation. This right here is not an equation of a function. Okay, this describes the transformations that need to happen to f of x. And here's f of x. So we start with the parent function of x to the power of 4, and then we put in our parameters. So we end up with y equals 2 square bracket, k is 1/3, round bracket, x minus 5, close out those brackets, to the power of 4. Not difficult, just have to distinguish. This is now an equation of our function, okay? This is a description of the transformations being made to the function. All right, quickly, domain and range. This is a quartic function with a equals 2. Quartic with a equals 2. Therefore, what do we know about it? It opens up. Vertex is at DC, so it's 5, 0. Axis of symmetry is the x equals the x coordinate of the vertex, so it's x equals 5. Domain, no restrictions. X belongs to the set of real numbers. Range, y has restrictions because it opens it up with a vertex at 0. So we've got y belongs to the set of real numbers such that y is greater than or equal to 0. Not so bad, right? Let's do one more.
Pretty straightforward.
Look at B. And while I'm copying it down, you try to notice something about B that makes it a little bit trickier.
The k is factored in.
Mm-hmm.
X and D.
Okay, so the parent function is f of x equals x to the power of 5. The transformations are described as y equals 1/4 times the function. And then we have a square bracket here with negative 2x plus 6. Close it off. Plus 4 on the outside. And we're noticing right away that the coefficient in front of x is not 1. That means we need to factor this thing. Needs to be factored. Maybe that's a terrible note. Let's say negative 2 needs to be factored out. So let's rewrite that. We've got y equals 1/4 times the function. And if we factor out negative 2, then inside the bracket, we have x minus 3 and plus 4. Again, that's still not the equation. It's just a description of the transformations being made to the parent function, f of x equals x to the power of 5. Okay? Parameters. A. Good job, 1/4. That's going to be a vertical compression by a factor of 4, 1/4. Okay? Then we have a k. K is negative 2, so that is a horizontal compression by a factor of negative 1/2. Then we have D, which is 3. That's going to cause a horizontal translation 3 to the right.
How many D is 3? That is negative 3.
Negative is in the,
That's not.
yep. C is 4. That's going to cause a vertical translation 4 units up. So let's write our new function. We've got y equals 1/4.
No, man. D is negative 3. Because when you factor negative 2 out of x, you take negative 2 out of 6, so you get negative 3.
Yeah, but the base function that we're working off of is y equals a k x minus d. n plus c. So
Oh,
if we have x minus d and we have x minus 3, so d is 3.
yeah, I see what you're saying.
It's a good reminder. Another common what do I do kind of situation. Okay, so we have a k of -2, then in bracket x minus 3. Close those brackets. It's to the power of 5. Notice that's really the only place it comes in. You lose the f and you put in the exponent. Okay? Otherwise, they look pretty much the same. Good. And really quickly, it is a quintic because it's to the power of 5. So it doesn't have opens up or opens down or anything like that. So we don't need to worry about the equation of the axis of symmetry. We just need to do domain. Domain, any restrictions?
Just x here.
X belongs to the set of real numbers, and range? Same. Y belongs to the set of real numbers.
We go from negative infinity of x to positive infinity.
You've got it. All right, practice problems for that is page 49. Page 49, numbers 1 through 8. Enjoy.